Okay, students, we will move on to do question number 6. The question is as follows. The first three terms of an AP are given to be as p squared over 6, comma 2p negative 6 and p. Question part A says that given that the common difference of the progression is not 0, find the value of p. Part B is using this value, what we have to do is find the sum to infinity of a geometric progression with the first two terms being given as p squared over 6 and 2p negative 6. Okay, this is an interesting question. So foremost, let me start the solution. So we are given the first three terms, p squared over 6, 2p negative 6 and p. Now, since this is an AP, the common difference will be the same. So this in turn would mean 2p negative 6 negative p squared over 6 will be same as p negative of 2p negative 6. So I take the LCM as 6 here. This is 12p negative 36 followed by negative p squared is equal to p negative 2p, that's going to be negative p, and positive 6. So you cross multiply, you get negative p squared negative 36 positive 12p is equal to negative 6p positive 36. You bring everything to the left, all of this, that's going to be negative p squared negative 36 positive 12p positive 6p negative 36 is equal to 0. Now these two can be added, these can be added, so that's going to be negative p squared positive 18p and negative 72 is equal to 0. Now I'm going to multiply by negative 1 throughout. That would give me positive p squared negative 18p positive 72 is equal to 0. Now from here, if I were to take 72 here and negative 18, I need to get two tables, two numbers, which when multiplied would give me 72 and added would give me 18, negative 18. So 12 times 6, that's 72, but when we add we need to get a negative 18, so I'm going to take negative sign over there. So having got these two values, this in turn would mean I have p negative 6 times p negative 12 is equal to 0. P times p is p squared p negative 12p negative 6p negative 18p and negative negative positive 72. That's fair enough. So from here p is equal to 6 and p is equal to 12. Now one of these only will be suitable for us because the common difference of the progression is not 0. So we have to ensure that that is actually held. In other words, we cannot breach that requirement or that condition. Now what I'm going to do is I'm going to take case 1. So case 1 is p is equal to 6. I take p is equal to 6 and then I substitute the value at the AP that we have here. So when p is equal to 6, the terms are, so what are the terms? The terms are p squared over 6, right? P squared over 6, that's going to be 36. 36 over 6 comma 2p minus 6, that's going to be 2 times 6 negative 6, and then you have 6, so that's going to be giving us 6, 2 6 12 12 negative 6, that's going to be 6, and you also have a 6 here. Now you find the common difference. Common difference is what? 6 minus 6 is 0. Common difference over here, again 6 minus 6 is equal to 0. So the common difference is actually 0. So this in turn would mean p is equal to 6 has to be dropped. Right, p is equal to 6 has to be dropped. It cannot satisfy our requirement. So let's see p is equal to 12. So the terms of the AP are p squared over 6 comma 2p negative 6, and you have p. So when p is equal to 12, this is going to be 12 squared, so 12 into 12 divided by 6, and p is equal to 12, that's going to be 12 negative 6 and 12. So 6 divides here 12 times, the number 12 2 times, so 24. This is 24 minus 6, that's 18, and you have a 12 here. So you see the common difference. The common difference is over here it's going to be 18 negative 24, that's negative 6, and over here 12 negative 18, that's negative 6. So the common difference is not equal to 0. So this means p is equal to 12 is the value. So that is actually true to us. Now we need to move on to the next part. What is the next part? The next part wants us to actually get the sum to infinity, right? So part B, we have to find the sum to infinity of a GP. Now we are given the following terms in the GP, right? We are given, let me write that, we are given the first two terms of the GP. So what are the first two terms? We are given p squared over 6 and 2p negative 6. Since p is equal to 12, we have got 12 squared over 6 and 2 times of 12 negative 6, which means this is going to give me 24, right? And this is going to give me 24 minus 6, that's going to be 18. So we have got these two terms. Now to get the common ratio, we need to find r. So to find the r, we have to have 2p negative 6 divided by p squared over 6. This is 18 and this is 24. So 6 3s are 18, 6 4s are 24, therefore r is equal to 3 over 4. Now sum to infinity, S infinity is a over 1 negative r. Now the first term, so what is the first term? We have already been given the first term as p squared over 6, and that has been evaluated to be as 24. So 24 divided by 1 negative 3 over 4. 24 over, this is 4 negative 3 over 4, which is 24 over 1 over 4, which is 24 multiplied with 4. 4 was a 16, 1 4 to the 8, 9. So sum to infinity, therefore sum to infinity is 96, right? So this is what we obtained. So we've got the value of p and the sum to infinity. So that completes the solution for this question. Okay, students.